Hi, everyone, and thank you for joining us. Our project explores Florida's labor market, specifically wage trends and disparities across 25 metro areas between 2015 and 2024. We have used the occupational employment and wage statistics dataset. It's quite large, so we have used Apache Spark to process it efficiently and analyze it at scale. The challenge we tackled is that this kind of wage data is usually static. Policymakers and economic developers don't have tools to make prediction or identify patterns like rising wage gaps or in-demand occupations. Our goal was to change that using data to generate forward-looking actionable insights. Our objectives were fourfold: explore patterns in wages and employment, identify regional wage disparities and top paying roles, predict wages using machine learning, and cluster occupations into segments to support policy and planning. The data came from the Bureau of Labor Statistics OEWS program. It includes occupation codes and titles, cities, employment levels, and wage metrics, specifically entry, mean, and experienced wages. We had a decade's worth of data at the city, occupation, and year level. Starting with the descriptive analysis, Miami, Fort Lauderdale led Florida in average wages, followed closely by Naples, Crestview, and Tampa. Wages here have hovered around $31 to $32 per hour. The highest paying jobs were largely in healthcare. Orthopedic surgeons, radiologists, and cardiologists topped the list, earning upwards of $140 per hour. Wage trends over the years showed that most cities experienced consistent growth. Miami maintained its lead throughout the period, reaching close to $33 per hour in 2024. Looking at specific occupations, pediatric surgeons had the most significant wage growth, nearly doubling. Meanwhile, emergency physicians saw a slight drop, and radiologists remained stable. We also ranked cities based on how many high paying jobs they offered. Tampa and Orlando had the highest counts of occupations, earning over $40 an hour. So, from this analysis, we saw where the top jobs were located, how they changed over time, and how cities differed in both average wages and occupational variety. Over to Sonal.
Thank you, Sumit. Now let us look at a spatial and occupational breakdown of wage disparities in Florida. We began by identifying the top paying occupations by city. In Daytona, orthopedic surgeons earn nearly $200 per hour. In Tampa and St. Pete, radiologists earn $191 per hour, followed by Crestview. These cities also show the highest wage gaps. Deltona, Lakeland, and Tampa all have the disparities of over $185 per hour, meaning that the difference between their highest and lowest paid roles is enormous. This highlights a growing intracity wage inequality even in smaller metro areas. To visualize this more clearly, we created a choropleth map of Florida, where each city is shaded based on its average hourly wage. Lighter areas like Miami and Tampa reflect higher pay levels, whereas the darker areas like Jacksonville show low averages. It's a powerful way to immediately spot economic concentration and underperforming regions. We also examined wage disparities by occupational group using two-digit SOC codes to generalize job types. We found that the management and healthcare practitioners had the highest wages, around $44 to $48 per hour on average. In contrast, the service related occupations like food prep, cleaning, and personal care were below $17 per hour. This occupational wage hierarchy reinforces that wages inequality isn't just regional, it's deeply sectoral. So we built a classification model to sort the occupations into wage bands like low, mid, and high income groups. We encountered a challenge here that was class imbalance. The mid wage roles were far more frequent than the high or low wage ones. To address this, we used Spark's explode and sequence function to oversample the underrepresented classes, creating a balanced data set, which helped us to reduce the bias and provide us more reliable classification. We evaluated our model using accuracy and F1 score and achieved an accuracy of 85%. And the results showed reliable and consistent classification across all wage bands. That is also prevalent from the confusion matrix. In short, this model offers a fast and fair way to categorize any job, helping the workforce agencies prioritize where support and upskilling are required the most. From here, we moved into the predictive analytics. We implemented a random forest regression model to predict the mean hourly wage. We got a R square of 0.85, meaning the model explains about 85% of wage variations across all roles. The most important predictor turned out to be occupation code, which confirms that what you do plays a bigger role than where you work. This model is useful for a wide range of stakeholders, like employers can use it to benchmark salaries, policymakers can simulate interventions, and job seekers can better understand earning potential based on role and skill set. Over to Shriya.
Thank you, Sonal. Let's talk about how we enhance the analysis with clustering and a recommendation system, turning data into actionable insights. First, we use K-means clustering to group occupations in Florida. This revealed three main clusters. First, the high wage cluster, which had healthcare roles like physicians earning over $45 per hour, mainly in cities like Miami. Next, the mid wage cluster, which had technical and managerial roles earning between $20 and $45 per hour, spread across large cities. And last was a low wage cluster, which had service roles such as food preparation, earning below $20 per hour, mainly in smaller areas. These low wage roles make up to over 40% of the jobs analyzed. Now, moving to the recommendation system, it is an interactive tool using content based filtering with cosine similarity. Users can enter a job title and instantly receive personalized career suggestions. For example, if someone searches for data analyst, the system suggests similar roles like business analyst, marketing analyst, financial analyst, and many such similar roles. The output isn't just a list of job titles, it provides each role's average wage, top hiring cities, and job demand. This means users get a clear view of potential career paths, including which cities offer the best pay and where demand is the highest. Together, clustering and recommendation system transforms raw data into clear insights, helping job seekers explore opportunities and guiding policymakers on wage improvements. With that, I'll now pass it to Priya.
Thanks, Shreya. Now let's shift from insights to impact, how our work applies in the real world. Our project has several real world applications. Policy makers can pinpoint wage inequality hotspots. Employers can benchmark salaries against regional and occupational data. Workforce boards can design programs for low wage clusters. And career counselors can offer evidence based guidance to job seekers. Moving to what's new in our approach. What's new in our work is that we combine descriptive analytics, predictive modeling, clustering, and recommendations, all inside a single Spark based pipeline. We automated class balancing, feature engineering, and data cleaning, which makes this approach scalable and repeatable. Moving to conclusion. In conclusion, we achieved all our objectives. We went beyond just analyzing trends. We predicted wages, segmented the labor market, and built a career recommendation engine. Moving to future scope. There's a huge potential to expand this further. We could integrate real time job postings for live labor market intelligence, scale the pipeline to other states or even nationally, and build a public facing interactive dashboard to empower policymakers, job seekers, and educators alike. Thank you all for listening. We truly appreciate your time and we are happy to take any questions or feedback you may have.